So we began this unit by looking at some rules for calculating the derivatives of functions. And we looked at how would you calculate the derivative if you had a function that was multiplied by a constant. And we looked at how you calculate the derivative if you had a function that could be thought of as two separate functions added together or subtracted from each other. Today we're going to look at two more of these rules. The first one is what's called the product rule. So we want to be able to find the derivative of a function that is formed by multiplying two functions together. And to do that, we are going to use the product rule. And of course, we always want to be able to use these derivatives to solve problems involving tangents, rates of change, and that kind of thing. So let's just take a look at what the product rule is. The product rule says that if you've got some function, f at x, which can be thought of as being made up of two simpler functions, g at x and h at x, which are multiplied together, then if we want to find the derivative, f primed at x, what we want to do is we want to take the derivative of that first function, g at x, and we want to multiply it by the second function, h at x. And then to this we want to add that first function, g at x, multiplied by the derivative of the second function, h primed at x. So f primed at x is g primed at x times h at x plus g at x times h primed at x. So the derivative of the first times the second plus the first function times the derivative of the second. Now, a slightly simpler way of writing this is imagine that your two functions, which both have to be functions of x, are u and v. And we'll just make that little note over here. U and v are functions of x. Then the product rule tells us that the derivative, f primed at x, is u primed times v plus u v primed. Okay? Derivative of u times v plus u times the derivative of v. So let's apply this to an actual function here. Let's say we want to find the derivative of the function y equals 3x to the power of 5 times 6x squared plus 8x. This is a function that we can think of as being two simpler functions multiplied together. Okay? Our first function, which we're going to call u here, is 3x to the power of 5. Our second function, I'll use green over here, which we are going to call v, is 6x squared plus 8x. So our derivative, let's call it y primed, is going to be u primed v plus u v primed. Now let's fill in what that's going to be for this actual function. What is u primed here? Well, if u is 3x to the power of 5, we can use the power rule to take the derivative of u. We're going to bring down that 5, so it's going to be 15x to the power of 4. And then we're going to multiply that by our original function v, which is 6x squared plus 8x. So we've got u primed, and then we've got v. To this, we are going to add our original function u, so 3x to the power of 5. And this is going to get multiplied by the derivative of the function v. So v primed is, let's see, if v is 6x squared plus 8x, its derivative is going to be, we've got to use the addition rule here, but it's going to be 12x plus 8. So that's u, and this is v prime. And there's our derivative. So from here we could expand, simplify, collect like terms, and things like that. Whether or not we want to do that is going to depend on what we are asked to do with the question. If we are asked to simplify, we would do that. We would expand, simplify, and collect like terms. If we were asked just to find the derivative, we'd probably just leave it like this. Or if we were asked to do something else, well, it would kind of depend, right? So let's look at an example where we are asked to do something specific with the derivative that we get. Here we're asked to find the slope of the tangent to the function f at x equals 3x squared plus 2 times 2x cubed minus 1 at the point 1, 5. Anytime we're asked to find the slope of the tangent, we know right away what we're going to have to do to our function. What are we going to have to do to our function to find the slope of the tangent? We are going to have to find the derivative. So let's find our derivative here. And once again, we've got a function that can be thought of as having one function times a second function. So I'm just going to write those letters under there, u and v. So our derivative here is going to be u primed times v plus uv primed. Okay, so the derivative of u is going to be, just 6x. U is 3x squared plus 2, so our derivative is just going to be 6x times our original function v, 2x cubed minus 1. Then we take our original function u, 3x squared plus 2, and we multiply that by the derivative of v. So we've got v as being 2x cubed minus 1, so we bring down the 3 to get 6x squared. So that's our derivative. Now, what do we want to do with this derivative now that we've found it? We want to use it to find the slope of the tangent at this point 1, 5. So what should we do from here? Yeah, we're just going to sub in 1 for x. So at 1, 5, we are going to evaluate f primed at 1. Now, there's two schools of thought here. Sometimes you should probably expand, simplify, collect like terms, make your expression as simple as possible before you start subbing in and evaluating. The exception to that rule is when the number that you're subbing in is going to make things really, really simple. So if we're subbing in 0, we might as well just sub it in right away. If we're subbing in 1, we might as well just sub it in right away because multiplying powers of 1 or multiplying something by 1 gives us something that's really simple. So I could even do this substitution in my head. 6 times 1 is just going to give me 6. 2 times 1 cubed, of course, is just going to give me 2. 3 times 1 squared is just going to give me 3 plus 2. And then 6 times 1 squared is just going to give me 6. And then I can simplify this here. So I have 6 times 1 plus 5 times 6, which is going to give me 36. So 36 is the slope of the tangent to that function at the point 1, 5. All right, we'll do one more example here. For the function y equals x squared plus 2x plus 1 squared, determine where the slope of the tangent is 0. So there's going to be 3 steps to solving this question here. If they tell us that we're interested in finding where the slope of the tangent is 0, well, once we see the word slope of the tangent in there, we know that we are going to want to find our derivative. What's our next step if we're trying to find where the slope of the tangent is 0? What are we going to do here? Malcolm? Sub 0 in for the derivative. So what are we going to, in our derivative expression, what are we going to replace by 0? Yeah, so we're going to set our derivative equal to 0, and then we are going to solve for x in this case. Okay, so we're not subbing in for x, we are solving for x because we're asked where the slope is going to be 0. So let's start with our derivative. Now, we don't actually have a function here that is a product of two functions. We have a function x squared plus 2x plus 1 that is squared. But we can immediately write that as x squared plus 2x plus 1 times x squared plus 2x plus 1. So it is a product of two functions. And again, we can think of this first bracket as u, and this second bracket as v. So our derivative is going to be derivative of that first term, so 2x plus 2, times the second, x squared plus 2x plus 1. So this is u primed v. And to this, we are going to add uv primed. So x squared plus 2x plus 2x plus 1 times the derivative of v is 2x plus 2. So uv primed. We want to set this whole thing equal to 0 and try to solve for x. So in this case, well, we are going to have to do some simplification on the left-hand side. Now, what's simplification? What's the quickest way to simplify this? Well, maybe I shouldn't say simplification. What's the first step you would do in order to make sense of what's going on here? What do you notice about these two terms that are separated by the addition sign? Right. They're the same. So we've got this plus this, so basically we have two of them. So this simplifies to 2x plus 2 times x squared plus 2x plus 1, which is pretty handy. Because how are we going to take this thing and solve for x? If we set something equal to 0 and we're solving for x, what operation are we going to have to do to solve for x? Right. We are going to have to factor. So rather than expanding and collecting like terms, we want to get this thing factored. So just by combining those two together with that 2 out front gets us something that is closer to being factored. So what factoring can we do in this expression that we have here? We've got a 2. Can we factor this first term in brackets here, 2x squared plus 2? Alana's nodding her head. She says, yes, we can factor out, common factor out a 2. What about that second term, x squared plus 2x plus 1? Does that factor? Well, it's a trinomial. So let's try factoring that as a trinomial. We'll have an x and an x, and a 1 and a 1, and a plus and a plus. So our factored form is going to be 4x plus 2 times x plus 1 times x plus 1. So what x values are going to make the slope of the tangent equal to 0? An x value of -2 and an x value of -1.
X plus 1 here.
Oh, thank you. So if I factored out that 2, I have an x plus 1. So we only have one solution then, x minus 1, which occurs 3 times.